In the 1960s, Professor Jose Delgado took a normally hostile bull and implanted electrodes into its brain. Electrodes that could be activated by a radio transmitter. His objective was to see if stimulation of the bull's midbrain could short-circuit the rage signals, stopping the bull before it reached the matador. After the bull had recovered from the implantation and in mid-charge, the button was pressed. The bull's aggression ceased instantly. A clearer experiment was performed with cats. In this classic example, the hypothalamus, the rhythm maker, was implanted with electrodes. Could it be responsible not just for rhythms, but also for rage? The switch is turned. Then the switch is turned on.
So imagine a young woman, she's just given birth, and then she needs to make the decision. Is she going to have her baby modified? Is she going to turn that baby into a cyborg? This grain of sand, in a sense, that's been nanoteched, is inserted into the human brain, the baby's brain, and it integrates itself into the brain. So that baby, in effect, is no longer human.
This is a man-made motor, a motor so small that more than 6,000 of them would fit on the head of a pin. Welcome to the world of the nanometer, a unit of measure that is 1/billionth of a meter.
A nanometer is pretty small. One of the best analogies that I like to use is to compare it with a human hair. If you take a hair off of the top of your head, you can see that it's very thin. And now if you take something that's 100,000 times thinner than that, that's a nanometer.
The ability to observe and construct things this small is at the heart of nanotechnology.
And some scientists predict that one day we could even have a thinking chip, a thinking chip, a thinking chip, a thinking chip.
He says, but the next step was this active chip, which they've tested out for many years. Implanted in the brain.
In the brain?
In the brain.
The behavioral change happens when you start to make a material so tiny that its electrons are squeezed into a space smaller than they prefer. It's called quantum confinement.
The smaller you make the crystal, the higher the energy of the electron will be. Its kinetic energy is increased, and that can be thought of as making its wavelength a bit shorter and forcing it into a box, into a box, into a box.
At the end of the discussion, the swine flu was mentioned, and a lady got up and declared the following. This is what this lady said. A friend of hers works for a pharmaceutical company in Vienna and told her that the swine flu injection needles indeed contain nanoparticles in the very tip of the needle.
It was frightening as hell just to read that. I mean, we're barely prepared for microchips in the arm and don't want it.
Yeah.
But in terms of in the brain, that's so beyond chilling that it's almost incomprehensible that it would get there without massive outcry. Now, it almost seems like the generation that is here now, you and I, we've got to be off the planet before they can pull that off.
They would love that, and that's the way it was worded in the 600-page the documentation that came out, which I have. I got someone to go into the university's website and get it all before they took it down. And the guy from Tokyo that helped us to design this latest model, because they've tried it since the 1960s on unsuspecting victims. it has a coating on it which literally interfaces with your genetic material, so you can't simply cut it out.
Right.
And it also interfaces in such a way that it attaches itself to the cortex, the little neurons in your brain. And they said this will be the end of individuality as we know it. Says once this is, the guy's words were from Tokyo. He said, when this is working and everyone has it, he said, there'll be no more individuality and no ability for the person to even perceive of themselves as a distinct, separate individual. He said, think of it more like the beehive, and that the beehive has for thousands of years has been the high occultic symbol, the occultic system. He said, you'll hear people's whispers of their thoughts going through your mind back to the central computers, and from the computers back to the people, a constant buzz in your head of thoughts. He says, but it will be impossible for a person to even begin to think of itself as a distinct, separate entity.
The individual is injected with nanoprobes, microscopic machines which attach themselves to the victim's blood cells and begin to immediately rewrite the victim's DNA.
Israel is trying to create a robot no bigger than a hornet that will be able to chase, photograph, and even kill its targets. An Israeli newspaper reports the bionic hornet is being developed to fight terrorists. The flying robot will be based on nanotechnology.
The extreme possibility is that because they are organic, molecular transistors could reproduce themselves like life. They could be part of machines that will grow as living cells grow. And if this could happen, the world of the nanobot would have moved a step closer.
One nanobot doesn't do much. You need trillions of them. How do you get trillions of them? Well, you need them to self-replicate. You need one nanobot to turn to 2 to 4 to 8 and scale itself up to trillions.
Ray Kurzweil is one of those who believe that in the future, huge numbers of these self-replicating machines could be programmed to target every diseased cell in our body.
Our immune system, because keeps us alive, but they're very slow. I actually watched my white blood cells destroy bacteria, and it took like an hour and a half. A nanorobot could do the job in seconds. It would be far more powerful at destroying pathogens and cancer cells.
Trillions of these tiny machines could even be swallowed in pill form. Their microscopic onboard computers, controlled perhaps by molecular transistors, will direct them through even the smallest blood vessels to destroy any infection they come across. And though the technical know-how may be decades in the future, one has even been given a name: a Resprosite. Resprosites could be injected into the victims of drowning. Once in the bloodstream, these nanobots would break down the excess molecules of carbon dioxide and release oxygen into the blood. They could mean the difference between life and death.
Ultimately, we're not going to go to doctors and have visits in the way that we do today. We're going to have systems in our body that are continually monitoring our body, detecting problems, and fixing them immediately.
This is one vision of what the brave new world could be like for our children. A vision where all diseases could be fought. Their lives could be extended by decades. All because of nanotechnology. But there could be another use for nanotechnology. Dr. John Alexander advises the commander of U.S. Special Operations. He believes that in decades to come, war would be fought using nanobots.
The battlefield of the future is going to look very different from the one of the past. You're not going to see large armies of infantry and armor arrayed against each other and fighting in the open.
Alexander believes that one day, the same technology that we hope will seek and destroy infections could be turned into the ultimate weapon. Nanobots could lie silently in the environment for years, sending back information about our enemies. They could even be our assassins. These killers could be programmed to know precisely who to attack.
You can target them very specifically so that they will attack people with only certain characteristics.
They could be sent to take out people in even the most secure locations. Once programmed, nothing could stop them.
Some of them will be small enough that you can actually introduce them into a person undetectably, and they can go in and punch holes in blood vessels.
And then, of course, there's gray goo. Creating nanobots is one thing, but can we be sure that we can control them? The fear is that to breed, they will need organic material. And as their numbers increase, they could turn on the environment around them. They could devour plants, animals, and ultimately, us.
What happens if that self-replication gets out of control? You'd have a non-biological cancer. It's called gray goo. It could just spread and eat up the whole world.
Could this be our future? A world transformed for good or evil by nanotechnology.
We have to realize that this is coming. It is profoundly risky. It's also profoundly beneficial. We can overcome age-old problems of suffering which have been with us, since time immemorial. And we have to work hard. I think it's the primary challenge of the 21st century to gain the benefits while we manage these perils.